Oh, I'm sorry.
All right, I'm going to share my screen. I should be able to do that as co-host. Is that all right?
Whatever you want to do. Dr. L's just like, here, get it organized.
No, don't give me that much free reign.
You can do whatever your heart desires.
All right, so here we are. And let me get this activated. This is from let's hope this works. This is going off the OneDrive. All right, kickoff. I guess everybody on here planning on forecasting or just along for the ride? Do we get thumbs up if you're forecasting? Oh, I was hoping for the virtual thumbs up. There we go. Ian got it. I should do the same, right? Okay, so I'm going to talk about what I sort of do, a little bit of kind of what a lot of times they'll tell you how to forecast, a little bit of what I do. And I know things are different on the Weather Challenge site this year. It looks like they don't have I don't know if they're going to reactivate them, but they normally have information for each city available, and they'll have like links for data, but it doesn't look like they have those active now, and they may not. So they may not be helping you as far as getting access to data. I know a lot of you are going to have your favorite places to go for weather information, which is great. Don't think of these as the only place to go to get some of this weather information. And there's probably new stuff I'm unaware of, and that's okay. So I'm going to start out with the forecast funnel. Of course, meteorologists like funnels, right? Funnel cake. It's all good. But a lot of times we think of getting the big picture first and then drilling slowly down to the smaller scale. Now, you may have days where you barely have time to eat a snack. I know how this goes. And you have to rush into a forecast, and you don't have the time to go through all this process. But that's okay. Sometimes it's about figuring out when you're going to need to spend more time on a forecast. And I already, anytime there's chances of precipitation, that's a time you're going to definitely have to spend some time, because that's a real easy way to just like totally blow your forecast, is by under forecasting, or as I often do, over forecasting precipitation. I try to tamp myself down, but it's hard to do that sometimes. So yes, sometimes you'll just know it's going to be a more difficult day, and that's the day you should probably spend more time on if you could range your schedule and stuff like that. But when we talk about global, like the big picture, you might first start out looking at jet stream patterns, where your high and low pressure systems and fronts are. And, you first want to get a situation of where you're starting at before you can really get a sense of where the forecast is going to go. So what's going on? Paying attention to those important weather features that help produce some exciting temperature changes or precipitation. And then, of course, drilling down to the local scale. Now, when you're looking at the local scale, gusting winds right now may not have as much impact on tomorrow's forecast, but you always have to be careful of looking at that 6Z. Remember, these forecasts go from 6Z to 6Z, which right now is 2 a.m. to 2 a.m. our time. So sometimes things happen at 2 a.m. that drive the forecast, and you gotta be careful for those hours. Even an hour off can make a big difference. Sometimes a front comes in before 6Z, and that impacts the forecast for the day, and you messed up the temperature because you thought that front wasn't gonna come in till well later. So we'll talk a little bit about timing. But again, the forecast funnel, the idea is start on a large scale and then kind of drill downwards. And how might this look like? Uh-oh. I don't know why that's being mean to me. All right. So large scale. You might start out looking at satellite imagery. Where are your clouds? Clouds can be a killer for your forecast. You didn't predict them, and now your temperature forecast is out to lunch, either because it came in during the daytime and you forecast now to high temperature, Or clouds came in at night and we didn't have that radiational cooling. So, and if you're going to use model data, which most of us do, you might want to check and make sure, wow, the observations now are pretty well in agreement with the model thought was going to be happening right now. I'll talk a little bit more about that, but is the front where the model thought it was, or is it already off, right? You know, you might have a delay in the model. It might be too fast with the front, it might be too slow. So sometimes you wanna, when you're looking at this big picture, is also see, are the models currently okay? Are they behind or ahead of the schedule? Surface analyses up our data plots, of course. On the small scale, regional satellite data, individual NextRad radars, these very localized products, or maybe even a radio sound if it's close by. But realize radar information is probably only going to be good for a short-term forecast because, you know, you're seeing stuff that's really close to your site. But it can help you kind of in the big picture if you're looking at kind of composites. Does the model have the current precipitation in the right location? Or it has it and there is no precipitation. Or the radar shows a lot of precipitation that the model doesn't have. So it's just kind of get a sense of, is the model currently okay? And that may give you something to think about. Do I stick with the model even though it doesn't look like it has the current situation well at hand? So again, examples of larger scale. So I guess we're starting out with Grand Rapids. I'm somewhat familiar. I worked in the National Weather Service forecast, well, not forecast office back then, National Weather Service WFO back then, the Muskegon, Michigan, which is just around the corner from Grand Rapids, out in western Michigan, along near Lake Michigan. But you can see today we're in the warm sector, right? So if you're thinking, okay, that's my big picture, we've got this southwest flow. We're in the warm sector of this cyclone that's well to the north. You know, just getting your situational awareness together. There's a front to the north, warm front or a stationary front, another warm front, and you know, you're already thinking, wow, is this weather system out to the west going to be your weather feature? We could see when we look at the satellite, there's clouds up in northern Wisconsin, up by Lake Superior, and then in Minnesota with that weather system. You can see there's a pretty significant upper level weather system here. That's the 250 millibars, so we're looking at jet stream level. We can see that jet dipping down, the big upper level trough associated with that low. So getting yourself kind of acquainted with what's going on. There's another big area of clouds to the south, right? And so if there's features you see and you don't understand what they're associated with, you might want to try to investigate a little more. Of course, that's the large scale. And then there's products that'll help you with more localized. Of course, I'm in aeronautics now, and I use aviationweather.gov a lot to look at METARs. And METARs are really good. This page is really good at integrating some satellite radar and the METARs, which are the National Weather Service FAA network of sensors. And those are the sensors that are going to be used to validate the forecasts. So they're often good to look at. So KGRR will be in there. So this will give you a broad look of all the METARs together. Sometimes you might want more than just the National Weather Service FAA data. So I go to MesoWest because they will combine data from multiple networks. So you can see here I've put a subset of the data near Grand Rapids on from all the networks available at MesoWest. And you can see there's a lot more fine detail. If you're, and again, fine detail, probably not more for a local, near-term forecast. But it might give you some idea of how the winds vary regionally. And why is that important? You might find that, wow, I keep over forecasting the wind speeds or under forecasting the wind speeds. You might be able to pick up how the site you're forecasting for compares to nearby stations. When you look at it, is Grand Rapids tend to be higher than the other locations, lower than the other locations. So sometimes you can use this more fine resolution information to help you out and find features. of interest. Lake Michigan, what could you find there? Just like we have a sea breeze, they can have seasonally a lake breeze, more predominant in the summertime, but sometimes you can see interesting wind shifts as that starts rolling inland. And then I have the SPC. They have some nice mesoscale analyses based on surface observations. I don't have a link there for them, but hopefully you know where to find the Storm Prediction Center. We have these regional analyses, and you can see up there that this is a temperature and I believe wind analysis, and you can see some cooler temperatures hovering over Lake Michigan. So this is a nice way to kind of look at a regional look. And of course, when you're looking at METARs, some of these you could drill down really into sub-mesoscale detail. So again, looking at what the current situation is. So I put some links in here for, you know, where could you go, where some of the places you can go. Like I said, there's a lot more. I have links here to some places for satellite information. These are clickable. There's other places. Now I do a lot. I go to Tropical Tidbits a lot because I like their how they present model data, and they also have satellite sections. So there's a lot of places to go for satellite and radar information. I just included a couple here. The Storm Prediction Center has radiosonde observations that you can click on as well. So a lot of the weather modeling sites actually for forecast, you can click a button on the point you're interested in, and it will give you a forecast of what the radiosonde would look like if it was launched in the future at these locations. So I have MesoWest in there. Weather Prediction Center has some nice, you know, surface plots of where the fronts are, right? Where your features of interest. So I have that as well, the Aviation Weather Center. So this is very observationally oriented information. Forecast information. And this is probably just tip of the bucket. All right. Now, you're a forecaster. You don't have to listen to anything, but you could just look at the observations and decide, yeah, I'm just going to forecast based on the observations. Probably not a great plan. Models are good. They're not perfect. And so one thing I'll say about forecasting is models have biases that you'll become aware of. And sometimes they run high, sometimes they run low. Track your information. You'll find out you're biased. So I realized I tend to over forecast precipitation by keeping track. Holy cow, I'm off on the high side once again. For winds, this is really important. I'll show you turns out we forecast for peak winds, peak sustained winds at the sites, not peak gust. And that'll often be higher than any of the model data. Now, they used to have the USL. I don't know if that's going to be available this year. It was much better at forecasting peak wind than just using some of the traditional sites, just the raw model output or some of the post-process model output. But realize that if you go too close to the models, they will frequently underestimate the peak winds. And again, keep track. Watch how the models are tracking. Go back to how you did the day before. I know it's easy to just, I have to rush and just kind of move forward, but if you don't look at how you've been doing, you won't self-correct yourself for your own biases. So, places you can go. The National Weather Service I always go there. What are they doing? I usually create a list, like what's the Weather Service forecast high-low? What's some of the model forecast high-low? I keep a little list of things and, you know, decide, do I think they're on the right track? Do I think it's going to be warmer than they think? And then I'll adjust from there. So, I mean, everybody does it. Everybody looks at other forecasts to kind of.
Professor Splitt, this is Professor Lazarus. Real quick, also at the Weather Service, it might help you guys to read their forecast discussions.
Absolutely.
Yeah. Okay.
Absolutely. Yeah, absolutely. They'll give you their thinking, and that you won't see from numerical weather prediction. It just does its thing. And you go to some other sites, maybe you go to weather.com, they're not going to necessarily have a whole description of why they're forecasting what they're forecasting. So Sometimes they're a bit detailed, but they're good to look at. Other places, I'll show some examples of the mediograms. Mediograms, you know, we used to think of those as just the observed weather, but now all these different models can be plotted as to what they're doing in the future, and you'll get some sense of the variation between models. And, you know, everybody has their favorite model, and everybody hates this model and thinks this one's better, and so forth. So the mediograms are a good way to look at all of these kinds of data. High resolution model, the HRR, I put that, it's more of a short-term model, and it's not going to get you all the way to 6Z the next evening, okay? But it's very good if you're worried about, you see a line of storms coming, and you're worried about whether they're going to get there before or after 6Z. Okay, and or something like that, or you're worried about, well, do I forecast precipitation or not, or do I think the cold front's going to come in and cool temperatures? So if you're worried about something happening close to 6Z, some of the near-term forecasts become important. Sometimes they're not as important. I don't always look at the HRR, but if I've got some critical thing going on near 6Z, I will look at it. Like I said, I use pivotal weather and tropical tidbits a lot to kind of just look at the forecast information. And I'll show you some examples of the SREF. It's a ensemble of one of the forecast models, which I think is a nice way to look at weather uncertainty. What days, you know, is everything kind of in agreement, or what days the models could have varying solutions. So I'll show you a couple of examples. And I know the University of Albany, now one of these sites may no longer be active. I added a second one. One of these should work. But other people have nice weather challenge sites, so you might find those out there and use them. I've also found that sometimes there's specialized sites, like for example, maybe you're forecasting in Michigan. Look to see if any of the universities in Michigan happen to be running, or any organization, because sometimes government organizations run these as well, special model just for their little area. And sometimes those are really useful too. So I'll look, hey, is anybody running the WRF and the weather research and forecast model at a high resolution that would give me even more detail potentially and help a forecast. So always check around to see if there's some additional resources depending on location. I know like UW out in Washington, they have a lot of model runs. So I found these and they can be useful. Okay, so models, right? They're just a prediction of what's going to happen, and they're going to vary from each other. So this is a little bit of a longer term forecast than we do for the weather challenge, but I just pulled this from today. We've got the GFS, 6-hourly average precip rate, and the NAM, and it's for the same time, valid at 18Z Monday. So it means this is the average rate between 12Z and 18Z, but you can see they're quite different. And if you're looking at Grand Rapids in southwest lower Michigan there, the NAM has it cleared out. The GFS has it just really getting rainy. All right, so what do? Right? That could, you know, so this is where you're going to have to look at, being dependent on one model can be very risky. Some models definitely are better than others. People tend to go with the GFS, but be aware of when the models are in disagreement, and that's when to kind of make sure one model isn't off in terms of where it's positioned. You know, wow, that model has the front way out ahead where it should be, so maybe I don't believe where it's going to be putting the precipitation. So again, you use this information, but realize, if you put all your eggs in one basket, like you just went with the NAM, and this is what turned out, wow, that's risky. Model output statistics. So we have our different numerical weather prediction models, like the GFS, the NAM, you have WRF. But some actually, the National Weather Service, the parent organization, or excuse me, NCEP, the National Center for Environmental Prediction, post-process and provide better information in theory. They take the data and they say, okay, the model keeps doing this, but we're going to correct it based on the observations historically. And there's all sorts of output. They have like text output that you see over here. So let me just do this, annotate. And let me do a little drawing on here. And let's do red. It's a little bit more easy to see. So this is a standard, and I use these. So here's your text product. And by the way, some of the mediograms I'm going to show in the future that show forecasts will pull the information out of these kind of products. So here is like 18Z today, and then this is the overnight low that's getting forecast. That's tomorrow's high being forecast. All right, but be careful of those boundaries. 6Z, well, that's a nice straight line, and 6Z, that's your forecast period. So pay attention to what's happening. Okay, 64 down to 60, you know, these are the at each 3 hours. But this is indicating at some point in between, it's dropping down to 60. All right, so this is kind of a max, a minimum and a maximum. And this shows you what they're forecasting at 15, at 18, at 21Z, all the way up to 6Z. I like watching those boundaries, making sure something interesting isn't happening here or here in that transition period. Like I said, they'll have wind direction, they'll have wind speed. So here's the wind speed peaking at 17. But like I said, that's typically an underestimate at what will actually verify. It may actually verify at 20 knots or 21 knots, depending. So be careful about, even the model output statistics can be biased, especially when you're, because we're specifically forecasting for peak wind, not the wind at any one individual 3 hour period. But this is a good thing to look at. And some things to look at, even in the MOS, is like, what is it doing with clouds? You'll see it's got a lot of broken clouds. Now, if you thought it was going to be clear and you thought the models were out to lunch and you thought, wow, it looks really clear and I just don't see why it's creating such cloudiness, you might end up forecasting a higher temperature than they do. So you might adjust it. Or if you think that it's going to be overcast instead of broken, you might lower your temperature, for example. So you could look at this other information to help you with that. Also remember that in some dramatic situations, the model output statistics won't necessarily capture some of the peaks and minimums. So if you're like in a real drought, like California is, maybe they're in a heat wave, it tends to underpredict heat waves and some of the cold waves. Very useful information because it's better than the raw model output, but don't expect it to be perfect, especially with rapidly kind of changing weather conditions. And they have graphical views. So I have the text product, and there's all sorts of stuff there. Temperature, well, I could go through some of those. I forget what some of these are. I don't use them as much. But of course, some of the basics: temperature, dew point, cloud coverage, wind direction, wind speed. These are probability of precipitation versus a quantitative amount, which are done in these categories. And this is where I forget what they've got: categories like 0, 1, 2, 3, 4, and they relate to a certain amount of precipitation. I tend to go to the websites that, like Pivotal Weather, that show the actual amount over a 24-hour period that the model's forecasting. There's other probabilistic information down here as well. They also go, you know, is it going to be snow or rain, ceilings, visibility, some more aviation-oriented stuff. You know, they might help you a little bit. But be careful about precipitation. You know, it's easy to bust. It could be, you know, 50% chance of a lot of precipitation, and you're like, what do I do? It either rains and it's 2 inches, or it doesn't rain and it's 0. And you know, you have to look at how you're going to get penalized on those. Swinging for the fences is usually not a good idea unless you're really confident that you're going to hit that. Oh, I think we're going to get dumped 3 inches. I think we're going to set up some coastal convergence and it's going to be right over this site, for example, and dump precipitation. Swinging for the fences can get you into big trouble. Now, if you're well behind at a site and you're getting towards the end of the forecast constants, kind of swinging to the fences might be the only way to get you to a better score. But I wouldn't generally do that until you're like really in a pickle towards the end. Let's clear that out. Okay. Oh, and I don't know why it does that, but it did. All right. Come on, mouse. There we go. All right, so this is one of a couple sites that give you some idea of variability. This one was at SREF. It's a collection of the same model run with different variations, and I picked Grand Rapids. It might be hard to see here, but you go to the website, you could see I've clicked, here's Lake Michigan, and I've clicked on here, and it's showing the past. So I clicked on one of the older model runs, and you can see they put the observed weather here, and then this is all like the future now. And you get some sense of where all the variations of the same model, all right, with little perturbations, show it fairly consistent. You can see that they're starting to spread out as you go way down in the future. Here, way out, you can see, wow, quite a spread in what the model output is. But for comparison, I went over to Los Angeles, and look how fast they get out of whack. There's almost like two different realities here. If you look at Los Angeles, there's a set of models that are way up high, and then there's like this nothing in between, and then there's a whole bunch of model runs that are lower. And then the average is like right in the middle. Now the odds are it's going to be one of these two solutions and not necessarily the one in the middle. So the advantage of looking at this is to get an idea of you know, is there agreement, or is it like bifurcating, or just going to very wide variability? Los Angeles, way down the road, you can see, just look at that variability. There's just a huge spread in that temperature information. Of course, we're worried about the near-term forecast from 6E to 6Z, but again, you might be concerned about this one because look, the temperature is increasing down the road, and these would be a much different forecast than the ones down here. The meteograms from Iowa State over here are similar, but it's not variations of a single model. You can see they have variations of the NAM, the GFS, model output statistics, the RAP. So this is more of a mix of different models and model output statistics. And they also have where the observations have been so far, and then you can see where the future goes. So they're really great to look at to give you some idea of, do I have a crazy day where there's a lot of variability and low confidence in the models, or do we have a day where the models are all very consistent with each other? And that could be useful in terms of confidence in the forecast. Do I trust the forecast? Or where you might need to spend more time delving into a forecast, like this bifurcation. That's like two different answers. So does one have a cold front? Would do one set have a cold front coming in and the other doesn't? That's why you might want to look. That's why knowing what the big picture was, because if you didn't know the big picture, like you didn't know there was a front coming, you might not know why the models are bifurcating like this. What's behind that, right? So knowing that big picture is a good idea. All right, so just some things. Peak wind can be often higher than the models. I tend to forecast higher than them all the time. I'm usually do pretty good on the wind forecast. Again, watch timing. You're forecasting from 6E to 6Z. It's not necessarily, and it's depending on the time zone. So pay attention to that. It's not midnight to midnight, but it could be near midnight. Yeah, highs can happen at midnight. So don't always look at the next day's afternoon temperature for your high temperature forecast. Sometimes you've got a really warm, you're in the warm sector of a cyclone at midnight, and the front comes through, and basically your temperatures dive bomb down significantly. The sun comes out the next day and they recover a little bit, but it turns out the high temperature actually was at 6Z for us, which is 2 a.m. right now. So be careful of that. That really can kill people. So again, check, are features ahead or behind schedule relative to the forecast? So if you're going to use these tropical tidbits views or pivotal weather views of the GFS model, kind of track how it's doing. Is the front in the right location now? Is it ahead or behind schedule? And like track MOS, but I would say don't only just track MOS, track yourself, track whatever models you are using to help you, track the weather service. You know, I find they can be biased too. Like I forecasted and then they were too low one day and I realized the next day they were too low again. So the weather service can have their bias as well. And be aware of them, because then you could self-correct so that you're not continually forecasting too high or low. And sometimes it's easier. Some sites, like the weather is so boring, you can lock on to some of these biases and they'll be kind of consistent for the whole 2-week period you're forecasting. Other times you're at a site where the weather's rapidly changing and you went from kind of mundane weather to dramatic weather, and it's hard to lock on to biases. But you will have sites where they're kind of boring and you can really improve your forecasts by noting biases. Climate and past weather. So I put this in here. A lot of the weather service, you can go to the weather service, and most of the stations we're forecasting for, there's a weather service office that will have their climate and past weather data. And for example, I'm just showing you how to get there. Hit the climate past weather button. You hit the low button. For example, this is for Dubuque, and they'll have their preliminary monthly climate data. And it's a good way you could track what's going on here. And that's where they go for getting the peak wind information. So I will just quickly draw that on here. You'll notice average wind speed, max speed. This is in miles per hour. But if you've never forecasted for a site, I would go here and say, what have been the peak winds over the last week? What do they get to? And if you have access to the old model data, you might even start tracking this a week ahead of time. If you have that kind of time, check in advance. You've got the data here, peak winds from the Weather Service. You could start looking at biases in advance of forecasting. So I would even start doing it now. Don't wait till Monday. You got time this weekend? Check out how the models are doing to the observed that we're getting at that location. Oops. Oops, oops, oops. Let me clear all that up. All right. Again, I'm stuck in that. Oh, there we go. And this is just an example. Sometimes the Weather Service has nice little historical plots, and it's sometimes nice to just know, have they been running above normal, below normal, if they've been really wet lately. You know, if they're in a drought, that could matter because soil moisture can impact the forecast. As you get more better at forecasting, you're going to start looking at data sets you normally didn't. What subtle things can impact the weather? Well, if your soils are dry, you can heat up quicker. If your soil's wet, you take longer because some of that energy goes to evapotranspiration. So these are kind of things that, you know, might help you as you get more skill at forecasting. I always like looking at where the weather observation station is, because sometimes that can make a difference. So this was Dubuque, but you could do the same thing for whatever station. I go tracking these things down, and you can find where this is where the surface observations are at this particular airport. But you'll notice there's a terminal building right over here. And guess what happens when winds come from the direction of that terminal building? As opposed to coming from the flat runways or grass.
They give you like affected because of the building?
They're going to get impacted. They tend to be more gusty from that direction. So I'm just showing this. If you look at the wind gustiness at that location, you'll notice from the direction of the terminal buildings, it's actually a little bit gusty. So this is really drilling down to detail that you probably wouldn't do, but sighting can actually matter at a location. So I would even drill down to like, where is this station that we're forecasting for relative to the airport? Wind roses are good to give you a sense of the climatology at the site. This was one I do from my AVMET 2 course. I have students do this, but we could see that they have a lot of their winds at Dubuque are from the southwest. You could get an idea of the typical ranges. There's other places to get this information. So I included this. If you go to IEM, you can get wind roses, which is just the climatological wind information available. You can also do it by months. This is an annual one, or where you could see in Grand Rapids, their dominant winds out of the west-southwest. You get an idea of how windy it can be there. So the frequency in terms of direction are the here, but the colorization is by wind speed. So you get a sense of, you know, they get a wind out of the north, right? Not so frequently. They get more winds out of the west-southwest, but you can see the speeds that they generally get at the site. So they're more likely to get a strong wind if it's out of the west-southwest than it is out of the north. So you could use these, like if you see the winds are coming from the north, this might calibrate your wind forecast. So this kind of information, again, if you're drilling down deeper as you get more experience, can be useful for your forecast. Advanced tools would be using things like IDV. I know Dr. L uses that a lot for weather briefing. That's intense usage. And like I said, you may only have a half hour to forecast in an evening. So you have to get sort of, you know, get your tool, used to the tools you like, and be able to go through them quick enough to get your forecast in time. Like I said, some days you'll have more time and you might be able to use some products that and spend more detail. Like delving into IDV, Genpack we don't use as much. I still use it occasionally, but Cave is out there. All of these are great tools to combine all this wonderful meteorological information, but it gets to take a lot of time. So again, if you have time to delve more deeply on those tricky days, that's great. But I know what happens. You've got all these tasks to do. So I find some tasks are well worth it. Tracking my forecast, getting an idea of the biases. But again, these advanced tools take a lot of work to use. And I think that's where I've stopped. I'll open up to some questions from you all. I know it's just splattered a whole bunch of information. I can make this PowerPoint available to everybody if you're interested in some of the weather links that I've provided. And so let me escape out of there. Comments, whatever, questions. It's Friday. What do you expect out of us, Mr. Splitt?
We have some comments on some new things we're doing this year, but I'm gonna let questions go first.
Okay. Are those in chat? I don't see what's going on.
No chat.
No chat. Nobody has a question? How many people want the presentation so they can have some of those links, or?
Hey.
I'll take the presentation.
Some hands up on that?
Por favor.
Okay, so I'll probably have to do this tomorrow, but I will send it along to Kathy, and you can make it available to everybody? Or should I just send it out to?
I don't care. I can do it.
So traditionally we've had, is that active right now? Dr. L usually runs the National Forecasting Contest list. Did he say he was going to get that list together?
I don't know. He didn't tell me anything. He literally told me when to talk to you. That's all I know.
Okay, I got you. Well, that was just about me talking about forecasting.
Yeah, now, he hasn't given me anything.
Sometimes, okay, that said, usually we have a list where we can send information out to people that are part of the weather challenge. Whether we have that or not is not a big deal. We can still pass information to people as part of it. We'll get that straightened out.
You can worst case use the FitzCampbell server. Because so many people are doing it this year, there's not that many people not doing it. There's maybe like a half a dozen, but like everyone's doing it this year. So worst case scenario. I don't know where
Okay.
Dr. O went. He just disappeared, but he's still here, but not.
No, I know he's got to deal with something. That said, and I can talk to him later. What I wanted to say is that, you know, discussing the weather is great, but you shouldn't be sharing your ultimate forecast. I'm forecasting 72 tomorrow, just giving you a hint. It's good to discuss the weather. So if you guys organize like a chat room or a place to discuss, we used to use that list I was talking about too. I would sometimes just get on there and say, hey y'all, look at the models. They're all forecasting a massive amount of precipitation. You might want to be aware not to make sure you get your forecast. And missing forecasts is a real awful thing. You get penalized severely. So again, that's one thing, trick of the trade. When you forecast, get something in down the road, because the worst thing that can happen, I will just go, give me model output down on day 3, because if you forget one day and then you get like the default forecast, it's like massive penalty time. So that's just a reminder. Like I said, sometimes I would send a note out, big rain coming in, don't forget, you know, pay attention to that down the road on Wednesday. But you could also discuss things like, you know, just the general weather scenario. You could say, what's the weather service saying is going on? Having these kind of discussions is great. If you guys create some kind of forum, I think that's a great idea. Sometimes people are a little bit, hold their cards to their chest. They don't want to tell anybody what they're thinking, which I understand because they want to be the one that wins. But it's a learning experience. And if some of you get together to discuss it without specific amounts or exact wind speeds, but talk about the situation. Talk about the fronts, the cyclones, the local mesoscale features that are going on. I think that's great to do, and I encourage you to do that. There gets to be a problem if you're starting to share numbers. They don't like that kind of thing, but we want weather discussions on this, I think is a good idea. So if there's a way we could do that.
Splitt, Mr. Splitt, you're coming right on to what our new thing is here.
Oh, I'm sorry.
No, you're good. You made a great intro into it. So this year, what we're trying to do is on Friday evenings, what we're going to do is sort of a weekly debrief, where we'll look at, the main
That's great. That's great.
So the idea is that we would first show roughly what happened, right? Maybe the big picture of what happened this week, and then forecasters could present what their thinking was for the week. So like, all right, so say someone had the trough go through and it didn't, or something like that. You could say, well, this was my thinking, and this is why I thought that. But you also, so it's sort of a combination of reviewing your forecasts and also seeing what actually happened. I don't know if that really makes sense.
And that's going to be done like in a Zoom session kind of.
Right, yeah. Right, and we decided to do it every Friday with the idea that if, because we don't want to necessarily be forecasting from this, but we want to give people an opportunity to maybe learn something.
It's about learning, and that should always be a part of this. And I know as a new forecaster, it's very intimidating, and you will have bad forecasts. I'll have bad forecasts, and you're gonna be all upset. That's okay. It's about learning. It's about participating. That's what this is about. So it's great. Post briefings are great. Like you're saying, this debrief is a great way to learn, so you do better the next time. That's great.
If anyone's interested, I know 90% of people have Facebook here. I can make a group chat for during the week if anybody wants one. Is anyone interested in that?
I'd be interested in that one.
Okay. There's a thumbs up. I just thought of that from what Splitt was saying before.
We will moderate it though for exact numbers.
Yeah, obviously.
Yeah, because right, there's what's considered good discussion about weather features without being very specific about numbers for a forecast, and alerting people to things. But scary enough, there was, I forget when this came up. This came up on one of the weather lists that one guy said he used to participate in their college weather discussion class, and they would discuss what was going on in the forecast contest, but he would purposely leave out information and, you know, to kind of mislead the other forecasters. And I thought, oh, is that evil?
Oh, this stuff is cut. This contest is cutthroat.
It can be.
It always has been. There have been allegations of cheating. I mean, by big universities orchestrating. I mean, I have been embroiled in some of these discussions offline, basically, with some of my colleagues. So it can get ugly. So I had a student years ago get very upset with me because in the old days we were running things sort of in the background. There was no web interface, and so I wasn't here to babysit the forecasts, basically the command line forecasts that students were doing back in the days when dinosaurs roamed the earth. And the student basically accused me of being negligent. I was going down to my best friend's funeral, so I wasn't around. So that's how ugly it can get. Trust me.
Now, people can be very, you know, being competitive is fine. It's great when we have people win. It's awesome.
Yeah.
But it's about learning. And we also, as a team, we want to lift up our team. And, you know, some people will struggle. And it's good for them to use this as a learning process. Sometimes we have new people that are just natural weather forecasters and do a great job. Other times to people, it's very disorienting of how to start doing it. And, you know, we want to get everybody a good learning experience. And this is really great. And having discussions, I think, is great. So this debriefing idea, I think, is good. Having discussions like on Facebook ahead of time, just to say, you know, what are the weather, you know, what's the big picture that we're worried about? I think that's really good stuff. So that's my 2 cents.
Thanks for all the information.
You're welcome, and I'll send, like I said, I'll forward the presentation over to Cassie to distribute wherever.
Wherever I want. Oh, I'll just send it to my mom. I'll just confuse the heck out of her.
Break a leg. Break a leg.
I'm always happy to confuse people.
I mean, Dr. O confuses my mom sometimes, so it's fine.
I like your mom.
The hairspray thing. Oh, the
All
hairspray. Yeah, fun times. Okay.
All right,
Anybody else have anything? We're good?
All right, let's go have a Friday night, folks. It's an exciting Friday evening.
Splitt, are you coming to our game day on Sunday? Our Pictionary?
I just found out. When is it running?
We talked about this at the last meeting where you're not paying attention. It's Sunday at 5 o'clock.
No, I knew it was Sunday. You know, I have so many things going on that I can't tell you what is going on when.
That's a mood.
So
Yeah, that's our way of telling you we don't know whether we're coming.
Pretty
or
much.
going.
Got it. Fun times. Well, that's a reminder for everyone else too.
Don't count on me, but I would.
Hi, Kate.
You know, I wouldn't mind joining at some point if I'm sane.
Good to see some people.
All right, well,
Z-Watt I just saw in the forest.
Good luck forecasting. Grand Rapids, right?
Yeah, they switched.
Yeah,
All right, it's time for dinner.
Okay, cool. Yeah, it's time for dinner.
I'm hungry. My stomach's growling, man.
I'm hungry too, so
It's
we're
nice-
ending this.
It's great looking. It's great
All right,
seeing all
buddy.
you guys.
y'all.
Bye, guys. Thanks for organizing this, Cassie.
Yeah,
Yeah, great job, Cass, Colin, gang. Appreciate it. Really awesome.
no probs.
Ciao.
Bye.